In this video, we're going to get practice on identifying the stereochemical label associated with the chiral compound. So here's the compound that we're going to start with, and we need to begin by identifying the priority of the four groups about our center of chirality, our stereochemical carbon, based on the priorities identified by the Cahn-Ingold pre-log rules. So let's start by recognizing we have a hydrogen, a carbon, a carbon, and a carbon. Already we know that that hydrogen is lowest priority. It's group number 4. Of our 3 other options, we have to see what is attached to the carbon to continue down the chain and determine priority. So we can start here and we see that we have a carbon that is bonded to an oxygen. Now, because it's a double bond, there's another oxygen, and then we have the hydrogen attached to it. We have an ethyl group, and that is going to be a carbon that is bonded to another carbon and 2 hydrogens. And then we have a methyl group that is a carbon attached to 3 hydrogens. We can clearly see that oxygen is higher priority than carbon or hydrogen, so this is priority group 1. Priority group 2 is up here because a carbon is higher priority than a hydrogen, and that makes this, the methyl group, priority group 3, with the hydrogen that we already identified as group 4. So if we want to identify our stereochemical label, we need group number 4 to be in the back, positioned away from us. But at the moment, this bond is coming out of the plane toward us. We need to reorient this molecule. There's a couple ways you could do this. One is you could try to mentally position yourself over here, looking at the molecule, so that the methyl is on one side of you, the ethyl is on the other side of you, the aldehyde is below you, and then we have the hydrogen going away from you. If you're going to find that challenging to say, I've got aldehyde, ethyl group, methyl group, that's a clockwise rotation, that's an R group, our stereochemical label. That's one way you could do it, but if you find that challenging, I'm going to give you a little bit of a trick. We could grab those 2 bonds mentally and rotate the molecule to another orientation. Let's try and do that. So in that case, I'm going to keep that aldehyde down at the bottom, but I'm grabbing this methyl and I'm pulling it around, moving the ethyl to this side. So now I've got the ethyl group over here. I've got my methyl group has come forward, and as a result of swinging around, that hydrogen has been pushed behind the backside of the molecule. We could put it there, we could mark it over here. Either of those is going to work for us. And now if we identify our priorities, we have group 1, group 2, group 3, and we see that is, in fact, a clockwise rotation, and this is our R stereoisomer. Now, that still may not be your favorite way to solve this. I'm going to give you one more technique. The third approach is to generate the enantiomer of our compound and identify its stereochemistry, and then we'll know what the original compound is because it's the opposite. To generate the enantiomer, you need to choose 2 of your groups from this original representation that you're going to switch. Since we want to put the hydrogen at the back, let's switch the hydrogen and the methyl group. So I'm going to leave my ethyl group up here. I'm going to put my aldehyde at the bottom, and I've switched the methyl and the hydrogen. This is not the same compound. This is its mirror image. With the hydrogen at the back, we can now determine what is the priority groups. We have priority 1, priority 2, and priority 3. And now it's a counterclockwise rotation, meaning that we have generated the S enantiomer. Since this is S, we therefore know that the original compound before we switch to pair is the R enantiomer. So now we're going to try a more complicated example where we have more than one stereochemical center. We're going to draw the compound out, identify our stereochemical labels at all locations, and name the compound, including that designation. Okay, we look at this and we can see we have 5 carbons. 3 of them are not chiral centers, but we have a chiral center here and a chiral center there. Let's start with the one at position 2. What's attached at this position? We have a alcohol, a hydrogen, a carbon, and a carbon. So we know that this is priority 1, this is priority 4, and now we have to compare our 2 carbons. The carbon over here is a carbon that is bonded to an H, and an H. Whereas this carbon right there is bonded to an oxygen, a carbon, and a hydrogen. So oxygen, carbon, hydrogen, listing them in order of priority based on the Canning-Gold pre-log rules. And we can see that the oxygen is higher priority. So this is going to be group 2, where this is group 3 about that carbon. So we can draw our circle going this direction. And we see that that's clockwise. So this is an R for its stereochemical label. Now let's consider the other center of chirality. This carbon has a hydrogen, an oxygen, a carbon, and a carbon, very similar to the one we just did, and we can assign our priorities as being priority 1, priority 4. We compare, this is a carbon with a carbon and 2 hydrogens on it. This is a carbon that has an oxygen, a carbon, and a hydrogen on it. And so this is actually going to be lower priority than that. We have group priority 2 and 3 for this center of chirality. 1 to 2 to 3 goes in that direction. That looks clockwise. But before you assign that stereochemical label as R, notice that our lowest priority group, the hydrogen, is not pointing away. Rather, our highest priority group is pointing away. We're on the wrong side of this molecule to be able to label its stereochemistry. So if we swap 2 groups, we generate the inverted stereochemistry center. So swapping those 2 groups, putting the hydrogen here and the OH here, is still going to end up with that R stereochemical label. So our original compound is the inversion of that, therefore it's actually S. So we can now name our compound. We have a 5-carbon chain, pentane. On that, we have an alcohol at position 2 and at position 3. So it's a 2,3 diol, and we need our stereochemical label at the start of the name, which is going to be 2R, 3S. Pentane, And because we have the prefix of diol, and we want to avoid having two consonants beside one another, we're going to maintain that E in pentane, whereas normally we would have dropped it off if it was a single alcohol group. So this is a 2,3-diol, and there's the name of our compound, including its stereochemical label.